All right. Okay, let's try another example here. Let's try another example for hypothesis test. Okay, so let's say you get in an argument with a friend, okay? And I don't know, what percent do you think the military or of the army is women? What do you think? 20? Okay, so you think 20% of the army is women? Okay, so let's say you're at the bar and and someone says 20% of the army is women. Okay. And then and someone else says, no, there's no way it's 20%. It's so does someone disagree?
5%.
Someone says it's not 20%. Okay, and they're not going to say 5%, but they're going to say it's got to be less than 20%. Okay. The U.S. Army. Okay, so we'll say 20% of the U.S. Army is women. So, okay, someone claims that, and someone else says, no, there's no way that's right. It's got to be less than 20%. Okay. So, you claim that it's less than 20%. 20% women. Okay. All right, and then so somehow we can take a random sample of people in the army. Okay, so maybe we don't go to the Pentagon and get all of these numbers, but we just take a random sample somehow. Okay, and I don't know how this is possible, but somehow we take a random sample of people in the army. Okay, so how many people should we sample?
600.
600. Okay. Huh? Okay. All right. These are pretty large numbers, but okay. So let's say we sample 600 people in the army, and let's say 90. Yeah. Okay. So let's say 90 are women. 90 are women. Is this evidence that the army is not 20% women? Or is this evidence that the army is less than 20% women?
Yes.
Yeah. Okay. Actually, these numbers might be too extreme. Let's say, what if I drew? Sorry, I'm changing up this number here. Let's say I get 100 are women. Okay. Sorry. Let's just do that. Is this evidence that less than 20% of that the army is less than 20% women? Yes? No? Okay. Well, how can we do this? Let's do a hypothesis test. All right. Does everyone understand what this question is going for? Okay. Someone's claiming that the army is 20% women. Okay. And then you say, somebody else says, you're saying, no, that's can't be 20%. It's got to be less than that. Okay. So somehow we take a random sample of 600 people in the army, and we count up how many people are women in this sample, and 100 people in this sample of 600 are women. So what is my p hat?
16%.
Okay, so my p hat is 100 divided by 600, so it's 0.1667. So my sample proportion is about 17% women. So is that proof or evidence that the Army is actually less than 20% women? Or is it possible that the Army really is 20% women, and my sample just happened to get less women than normal? Just because it's a random sample, right? Anytime you take a random sample, you don't know what you're going to get. So is it possible that I got, just because of random chance, that I only got 16.7% women? So what's more likely? So who says this provides evidence that the Army is less than 20% women? And who says this could have happened just by random chance? Okay. Well, can we figure out the answer? All right, so let's set up some hypotheses. What is my hypothesis? Yeah, so how would I write the Army is, so the null hypothesis is that the Army is 20% women. But how can I write that symbolically? Yeah, so I would write P, not P hat, P is 0.2, or 0.20, whatever you want to write. And what is the alternative? The Army is less than 20% women. So I would write P is less than 0.20. Okay, I actually forgot a step as I was going over this last time. So we have to, we can figure out the probability of getting only 16.7% women in a sample. We can figure out that probability. At some point, we need to draw a line and say, this probability is too small, then I'm going to have to reject my initial assumption. And then, or if it's larger than that probability, I'm going to say, you know what, this probability is big enough where I can't ignore it, and maybe it actually did happen by random chance, right? Because you guys are saying there's a decent chance of me getting a sample and getting only 17% women, right? That's what, those of you guys who raise your hand, that's what you're saying. So if you got to say, in your mind, what is a big enough probability where this could happen by random chance? We don't know, but a lot of times we pick a level called the significance level. Okay, which is also known as alpha, looks like an A, and the most common value is 0.05, okay? But sometimes alpha can be 1% or 10% or 2%, okay? Alpha equals to 0.05 is most common, but alpha equal to 1% or 10% or alpha equal to 0.02 are acceptable also. Okay, really any value basically between 1% and 10% is fine. So let's figure out what is the probability of getting 0.1667. What is the probability of getting a sample? So you guys are, when I said, is this evidence that the Army is less than 20% women? A lot of you guys, only a couple of you raised your hands. And if I said, is it possible that this happened just by random chance? A lot of you guys raised your hand. And it is possible, but let's figure out that probability. So what is the probability that I get only 0.1667% women, or not percent, proportion women? What is the probability that the proportion of women is 0.1667 or less if the Army truly is 20% women. Okay, so if the null hypothesis were true, p hats come from a normal distribution, and what is the mean? 0.2. That the mean of my sampling distribution is 0.2, and what's my standard error or standard deviation in this case? The square root of what? 0.2 times 0.8, 1 minus 0.2, divided by over 600.
0.0163.
Okay, so let's. So I get my standard error is 0.01633. Are we good there? So right here I put, what number do I put right here in the middle? 0.2. And I want to know what's the probability of getting 0.1667 or less. I want to know what's the probability of getting this or less.
Wait, where did we get that? Oh, that's from. Sorry. Okay.
Okay. So my test statistic what is my test statistic? 0.1667, my z-score, minus 0.2 divided by 0.01633. Okay, people came up to me after during the break asking questions. So if you had questions about it, do you still have questions now? Or we're okay? So what's my answer here? What's my z-score? Negative 2.039. So I'm going to just round off to negative 2.04. Is that all right? Negative 2.04. So what is the probability of getting 0.1667 or less? What's the probability there? .0207. So really about 2%. 2%. So I mean, it's a coincidence that this number is similar to the last example's number, but okay. So what do we say? When I take a sample of 600 people in the Army and only 100 of them are women, is this evidence that the Army is less than 20% women? Yes, no?
Yeah.
Okay, so someone's saying the Army's 20% women, another person says, no, it's got to be less than that. Okay, well, let's go to the Army and take a random sample. We randomly sample 600 people, and 100 of them are women. So my proportion that's women is 16.7%. And we're saying 16.7%, that's less than 20%. But could it have happened by random chance? Maybe, okay. Well, what is the probability that I take a random sample and I get only 16.7%? What's the probability that that happened just by random chance? 2%. 2%. So, we're faced with a dilemma here, okay? Do we say that, yes, my random sample was one of the 2% of random samples that produce only 16.7% women? Or do I say, you know what, maybe the initial assumption about the Army being 20% women is wrong, and that the Army is actually less than 20% women? What would you guys say? Yeah.
The initial assumption's wrong.
Yeah, we're gonna say that the initial assumption is wrong, okay? And so here, if we didn't, if we weren't sure where to draw the line, this is where the significance level comes into play. So this 0.0207, we gave it a special name. Do you guys remember what that was? It's the p-value. The p-value is the probability of observing your data or something more extreme if the null hypothesis were true. So my p-value is 0.0207. And what I look at is I look at my p-value versus the significance level.
Professor?
Yes.
Where did you get the significance level from?
I just picked it arbitrarily. Okay? So I said the most common value is 5%, but it is just an arbitrary number. Okay? But a lot of times textbooks and researchers and stuff will just pick 5%. It's an arbitrary value, but we're going to compare 2% versus 5%.
Wait, I was like,
You have a question?
didn't you say that we could choose 1%, 10%?
Yes, we can.
Then would it matter if we chose?
It does. It does.
1%?
Yes. Okay. So let's say. So these are all very good questions. Okay. So for now, we're going to say my significance level, my alpha is 5%. Okay. So the p-value is equal to 0.0207. The p-value is less than alpha. Okay, so this means we're going to reject our initial assumption. We're going to reject the null hypothesis. Page 0, and we conclude, or we say we have evidence that the proportion of women in the Army is less than 20%. Okay. And yes, we can pick different levels of alpha. We have a question.
I'm sorry, the 2% is applied to the 20% or to the 100 out of 600? Is there a 2% chance that 20% of the Army is women, or is there a 2% chance that out of 600 people, 100 of them are going to be women?
It's a 2% chance that if the Army were 20% women, there's a 2% chance of getting a random sample where only 17% are women. Okay? It's a 2% chance of the data being 17% or 16.7% women if the Army truly was 20% women. Yes, we can pick alpha 1% or alpha 10%. So if alpha was 10%, would I reject or not reject the null hypothesis?
Well,
I would, because my p-value is less than alpha. If alpha was 10%, my p-value is less than alpha, I would reject the null hypothesis. If my... we have a question.
I know this is going to be way wrong, but is it, so I can understand in my brain, so is the alpha the significance level sort of like margin of error, that if you hit a certain number then you know definitely your answer is wrong, and then that's how you can describe what your final answer would be? I know that it's a different way of, because for this right now, we got it lower than 0.5 or 0.05.
Okay, I don't mean to be rude here, okay? But I'm going to stop you there because I think what you're saying is very wrong, and maybe what you're saying about the margin of error is also wrong, and so I'm sorry. All right.
No, it's fine.
Okay. Sorry, I'm trying to gentle about it, but I should just stop you there. Yeah. Okay, Scott.
I was just wondering, is the 5.05 alpha popular basically as a flip side of the 95% confidence interval, more or less?
That is true. That is true. 95% and 5% go together because those are popular numbers and they go together in that route. But we don't have to worry about that so much. Okay. All right. But if I chose alpha 1%, okay, if my alpha was 1%, my p-value would be greater than alpha. Okay. And in that case, I would not reject the null hypothesis. And so there's implications. And so somebody could look at this data and say 0.1667 is less than 20%. I did the test. I got a 2% p-value of 2%. That gives me evidence that the proportion of women in the Army is less than 20%. Someone else could do the same analysis, do the same thing, get a p-value of 2% or a 0.02, and then but use an alpha of 1% and say, you know what? I'm not confident that the Army is less than 20% women. Because for me to be confident, I've got to get a p-value of 1% or less. Okay? And that's also a valid conclusion, that they would have to explain that, and they would need to say that they selected an alpha of 1%. And we'll talk about, you know, I know I said it's arbitrary, but there is some reasoning behind picking an alpha of 5% or 1% or 10%, and it depends on the situation that you're in. Okay? It depends on the situation that you're in. We'll talk about that in a couple weeks, about whether we should pick a large or small alpha. Yes?
When you said greater, is it 1% and less, or like less than 1%? If you use the alpha of 1%, 0.01,
Yeah.
it would have to be 0.01 or less than 0.01.
It doesn't really matter, okay? I mean, almost never will you get exactly 0.01, okay, for your p-value. Your p-values will probably almost never be exactly 0.02 or 0.01. It will almost never be exactly your alpha. So you will probably never have to deal with that situation, but it doesn't really matter. Generally, we say less than 1% or less than 2% or less than 5%. But I know we're trying to always look for these hard, clean-cut rules, but real life isn't like that, and statistics is kind of applying math to real life. So there's not always going to be clean-cut answers. Okay, so here we say we have evidence that the proportion of women in the Army is less than 20%. Okay, if we chose alpha equal to 0.01, then my p-value is equal to 0.0207, and here the p-value is greater than alpha. So we do not reject the null hypothesis. Okay? And we say we do not have enough evidence to say that the proportion of women in the Army is less than 20%. Okay? And that's okay. That's okay. There is a key here. Notice I say we do not reject the null and we do not have evidence. I never said we accept the null or something like that, okay? Because the null hypothesis says that the Army is 20% women. When I took a sample of 600 and found that only 16.7% of the sample was women, we can say that's evidence that the Army is less than 20% women. Or we can say it's not enough evidence to say that the Army is less than 20% women. Okay? And it depends on someone, you know, how, I guess, conservative someone wants to be, right? So somebody can say, oh, this evidence, this is pretty good. I'm convinced that the Army is not 20% women, okay? Someone else might be like, you know what, I want to be absolutely sure before I make any kind of changes and say that the Army's not 20% women. So you've got to really convince me with an alpha less than 1% before I make this conclusion. So yes, I see what you're saying. I see that your sample showed that only 16.7% of your sample was women, but that's still not enough for me, okay? And it doesn't prove that the Army is 20% women. It's just that this data is not enough evidence for me to say that it's less than 20% women. Is that okay? Yes?
And as long as we're given the significance level, like if I have to figure it out
Yeah.
on my own. Right
So
now,
I would on tests and things like that, I would tell you the significance level. Okay, or if the significance level is not stated, assume 5%. Okay, that's the most common, like over 80% of things go with 5% significance level. So if you don't see any significance level, just assume that it's 5%. Alright. So let's we'll move on, okay? Is this alright? So now we might be in situations where we're dealing with two samples and two populations, okay? Okay, so let's say, I don't know, what's a popular TV show?
Breaking Bad.
Huh?
Breaking Bad.
Breaking Bad, okay.
Game of Thrones.
Huh?
Game of Thrones.
Game of Thrones, okay. Well, we'll go with alright, we'll say, you know, what proportion of people, let's say we want to know what proportion of people watch Breaking Bad, and let's say somebody says, I think more women, or let's say, I think more men watch Breaking Bad than women. Who would agree with that statement? Okay, and who disagrees with that? Okay, if someone says, no, I think Breaking Bad is equally popular among men and women, and someone else says, no, I think Breaking Bad is more popular among men. Okay, so we go out and we collect data. This is how we settle all our arguments these days, right? So if someone says, I think Breaking Bad is equally popular among men and women. And someone else says, I think it is more popular among men. Who knows? So, okay, we go out and we collect data, and we're going to use this to settle our argument. Okay, if I were to set up null and alternative hypotheses, what would they look like? So my null hypothesis here is I'm going to say the proportion of men who watch Breaking Bad minus the proportion of women who watch Breaking Bad. If they were equal, this value should be 0. So I'm saying that the difference between the proportion of men who watch Breaking Bad and the proportion of women who watch Breaking Bad is 0, that there's no difference between those proportions. Okay? Alternatively, I could also write proportion of men equals proportion women. This is proportion of men who watch Breaking Bad or proportion of women who watch Breaking Bad. Okay? If the alternative is that it's more popular among men, what would I put here? Greater than 0. If Breaking Bad is more popular among men, this should be greater than 0. So the proportion of men who watch Breaking Bad minus the proportion of women who watch Breaking Bad is greater than 0. Okay, so let's say you go out and you survey. How many men did we survey?
200.
Okay, so our sample size n. This is going to be number of men who watch. Number of men total was 200, and out of those 200 men, how many watched Breaking Bad? That's
560.
no.
Wow.
Is this a random sample of 200 or 200 of your friends here? Okay. Okay. No TV show on Earth is gonna have over like 50% viewers here. Okay, so let's just say this was. I will be very generous, and I'm gonna say 50. Okay, that's 25% of viewers. 25% of men watch a show. That's pretty. If you're in entertainment, that's a huge number here. Okay. Huh? It is a huge show, but you get something like that. Okay. All right. And how many women did we survey? 300. Sure. And how many of the women watched Breaking Bad? 10. No. Okay. This is we got to get something at least somewhat comparable here. Okay. So, huh?
75.
Okay, 75 would be dead heat. So let's say 60. Well, okay. 62. I don't know. No, 60. 60 is fine. Okay, yes.
So you don't need to have the same number of men and women.
You don't need to have the same number of men and women. Otherwise, we would our studies would be very limited because a lot of times it's just hard to get the exact numbers. Okay, so you don't need to have the same number of men and women. Okay, what is the proportion of men who watch Breaking Bad? 50 over 200, 0.25. What is the proportion of women who watch Breaking Bad? 60 over 300, 0.20. Okay, so someone says, see, I told you, 20% of your sample. So when we took samples, only 20% of women watched Breaking Bad, and 25% of men watched Breaking Bad. See, that proves it. Would you say yes or no? You'd say, hold on, okay? This is what we're always going to be saying, right? We say, hang on. It's very possible that Breaking Bad is equally popular among men and women, and just when we took a random sample, because whenever you take random samples, you don't know what you're going to get. Maybe you happen to get a sample where more men like Breaking Bad, and you happen to get a sample where fewer women like Breaking Bad. Maybe the true proportion is somewhere in between, like 22% of everybody likes Breaking Bad, and you just happen to get a few more men and a few less women that watch the show. Would you say, oh, okay, I didn't think about that. Maybe that's true. Okay. All right. So we've got to say this. We got to test this out. Okay. So we want to know, well, if the proportion, if Breaking Bad is equally popular among men and women, anytime I take a random sample, the difference between them should be 0. Okay? What is the difference that I actually got? 0.05. Okay? The difference. So we expect a difference of 0. The actual difference of p hat for men minus p hat for women is 0.25 minus 0.20 is actually a difference of 0.05. a five percentage point difference in viewers who watch Breaking Bad. So is that 5% point difference, is that a big difference? Or could it be attributed just to random chance? Well, let's do the math, okay? Rather than just going wishy-washy and saying, 5%, not so big, okay? All right. So to answer this, well, we're going to have basically a normal distribution. What is the center?
Yeah.
No?
Zero.
Zero. Because every time I take a random sample and I look at the difference, if the null hypothesis were true, I should be getting a difference of 0. Okay? And I'm getting a difference of 0.05. Is this a big difference or not? That's what we want to know. Okay? Because if the proportions were equal, anytime I take a random sample, I should be getting a difference of 0. This is the sampling distribution of basically p hat men minus p hat women. Okay? What should that be? It should be centered at 0. Okay, the other piece that we need is the standard error, or the standard deviation in this thing, okay? Now, this is the unfortunate part. It's just this crazy ugly formula, and there's nothing we can do about it, okay? But it's just a standard error. There's nothing to be scared of, okay? You see a formula, you get scared sometimes. It's nothing scary. It's just, to get a z-score, what do? I would do 0.05 minus 0 divided by the standard error, okay? So it's nothing scary. We just follow the same process. It's just the standard error is this ugly formula. Okay, so the standard error is equal to p hat times 1 minus p hat times 1 over n1 plus 1 over n2, entire thing, square root. Okay, that's it. Not too bad. It's not too bad. Okay, but I also have to tell you, I never actually told you what p hat is. Okay, so p hat is actually x1 plus x2, or the total number of successes over the total number of observations. Okay, so you got to figure this out, and you got to plug that in, and then you get your standard error. But once you do that, it's easy. Okay. Okay, so this is total yes or success divided by total observed. Basically, this is just the overall proportion of everyone total, how many watch Breaking Bad. Okay? So, okay, did you guys get that written down? I'll give you a moment. Keep writing. Okay, we good? Alright, so what is my p hat overall? This is everybody. How many people total watch Breaking Bad? 50 plus 60. And so 110 people total watch Breaking Bad. And how many people total did I survey? 200 plus 300. A total of 500 people. So this is 0.22. 22% of everybody that I surveyed watched Breaking Bad. So what is my standard error? You just have to plug this into a formula. So make sure you guys can use your calculators. 0.22 times 1 minus 0.22 times 1 over 200 plus 1 over 300. Okay? 1 over 200 plus 1 over 300 is not 1 over 500. Okay? It's not. So don't do that. Huh?
Making fun of a fellow.
Does that say total?
I'm Breaking Bad.
Wait, was that mean or something to say that?
No.
Okay. Because it's a very common mistake. I see that in people's tests and homeworks. They're trying to take a shortcut. It will not work. So what did we get for the standard error here?
0.00143.
I didn't get that. Let me check my work again.
0.0378.
Yeah, that's what I got. 0.037815. Okay, so we'll just say 0.0378. Okay. What is my z-score then, or test statistic? So my z-score or test statistic is going to be 0.05 minus 0 over 0.0378. Where did this 0.05 come from? The difference of p hat here, okay? So sometimes you will see the test statistic written as this. Is equal to p1 hat minus p2 hat minus 0. So they'll just do p1 hat minus p2 hat over the standard error, okay? But I like to put in the minus 0 so you can actually see how it's a z-score, because it's 0.05 minus the mean of 0 divided by the standard error. So my z-score is 1.322. Okay, 1.32. So then what's the probability that I end up at 5% or more if it's if my z-score is 1.32? Yeah, 0.0934. Yes.
If you weren't gonna do that on a calculator, because I don't have like a scientific calculator, how do the steps go to multiply that equation out?
This thing?
Yeah. What do you multiply first?
You do 1 over 200 plus 1 over 300. Figure out that quantity. Then multiply these numbers, and then take the square root.
Okay.
Your life's going to be a lot harder without a scientific calculator.
Yeah.
You can do it, but it's like going to a bicycle race with a single speed or something, you know? Yeah, you can do it, but not advised. Okay. All right, so 0.0934. What do we call this value?
P-value.
This is the p-value. And this is the answer. What is the question where the answer is 0.0934? What is the probability of no?
Oh, them being equal.
No? Okay.
Yeah.
This is the answer to the question of if men and women, if Breaking Bad were equally popular among men and women, what's the probability, or I take a sample and I observe a 5 percentage point difference in popularity between men and women? Does that make sense? Because that's what happened. When we gathered data, we saw a 5 percentage point difference in the popularity of Breaking Bad. Okay? But the question is, if Breaking Bad were equally popular, what's the probability of taking a sample and observing a 5 percentage point popularity difference?
9.3.
The answer is 9.3%. Okay? So I'm going to erase this over here. Because remember, the p-value is if the null hypothesis were true. And what did the null hypothesis state? That Breaking Bad is equally popular, right? So, if Breaking Bad is equally, or were equally popular among men and women, what is the probability get a random sample, or get random samples where the popularity difference is 0.05 or more. Okay, and that answer, the answer is our p-value. .0934. Okay. So it doesn't happen all the time, but if we were to take another random sample, there's another set of random samples, there's about a 1 in 11, about a 9% chance that we get a 5 percentage point popularity difference just because it's random sampling. So, would we say this is evidence? This 5 percentage point popularity difference, is that evidence that Breaking Bad is more popular among men than women?
Yes.
It depends on our significance level. So, what significance level should we use? Let's say alpha is equal to 5%. Then what do I say?
No,
I would say my p-value is bigger than alpha. Yeah, my p-value is greater than alpha, so we do not reject what? Reject the null hypothesis, which states
That men and women watch it equally.
yeah, so which states that it is equally popular among men and women. Does it prove that it's equally popular among men and women? No. It's just saying you gathered this data and it's not enough to convince me. It's not enough evidence to convince me that there's a popularity difference. Okay. So we do not have evidence that there is a difference in popularity. How are we feeling? We have a question.
The closer it is to 10%,
Uh-huh.
that means it's like more like you're more correct about not rejecting it.
So the larger the p-value is, just means it's very likely that this thing happened by random chance. Okay? So I'm trying to think. I don't know if that answers your question or what. Okay. So yeah, the greater the p-value, it means it's very likely. So if your p-value is large, it just means it's very likely that you observed your data simply based on random chance. Okay? Yes?
The closer the p-value is to the alpha, though, is that what makes it more correct or less correct?
No, there's no more correct or less correct. Okay?
No, but I mean, like, if it's like for this
So
example.
if your p-value is less than alpha, you reject the null hypothesis. If your p-value is greater than alpha, you do not reject the null hypothesis. The truth is, you don't know if you made the right decision or not. Okay? You don't know. Because what could have happened, what could be the case is that maybe Breaking Bad is actually more popular among men than women. But maybe that difference is really small, like 1% difference. Maybe 21% of men watch it and 20% of women watch it. Okay, so there really is a difference in popularity. But when you do this test, it's not enough, you see a difference, but it's not enough of a difference to conclude that there's a difference in popularity. So you say, I don't have enough evidence to reject the idea that it's equally popular. But the truth is that there is actually a popularity difference. It's just really small. Okay? So the bottom line is, when you do these hypothesis tests, you don't know whether or not you're right. Okay? But you're just kind of counting on statistics and probability to get you in the right direction. Another example? Or okay, we'll do one more example here. Yes, question.
I'm sorry to backtrack, but
That's okay.
calculate the p-value.
Uh-huh. The 0.0934?
Yeah.
How did I get that? Okay, I looked at my z-score in the z-table. So my z-score is 1.32.
Yeah.
And so
then
if you look that
at
up,
the chart.
you get like 0.9066 or something, okay? And I did 0.9066 because it's always the area to the left.
Yeah.
I subtract that from 1 to get 0.0934. Okay. So I'll leave up the formulas for standard error and p hat, okay? But let's see if you can we can do this. All right, so okay, is okay. Are men or women better drivers? Okay. Now this is may not settle the debate. Okay. But we ask. So we're going to say, is there a difference in the proportion of men who've been in car accidents and we'll say at fault accidents, okay, car accidents, and the proportion of women who've been in car accidents. Okay. And so, so we survey a number of men and a number of women. How many men did we survey? 500. We're going with these huge numbers. Okay, 500 men. How many women did we survey? 300. Okay. 500 men, 300 women. How many of the men have been in accidents? 2 people?
23.
Huh? 220?
Yeah.
What?
I don't know.
That's crazy.
20%? Maybe. I don't know.
Yeah.
Okay, and oh yeah, that is 50%. Okay, so that maybe that's too big. Okay, let's say
120.
120. Okay, 120 is a good number that I can go with. Okay. Okay, and so how many women have been in car accidents?
300.
200.
Okay, we'll say 60. Okay, 60 out of the 300. Oh, okay. So sorry, this is not n. This is n.
Yes.
Okay. Alright, so this is the data, and this is all you need to answer your question. And let's say use alpha equal to 5%. Alright, do you want me to guide you, or?
Yeah.
Okay.
Let's try it first.
Or you want to try it out on your own? Oh, yes.
Try it.
Huh? Do it. Okay. Alright, so let's set up our null and our alternative hypotheses. The null hypothesis would state that what?
Difference between men and women.
No. The null hypothesis will always have an equal sign. Okay, this is a way to help you. What's the null and what's the alternative? Null hypothesis always has an equal. Okay? And this is for all hypothesis tests, okay? So I would say what? The proportion of men who've been in car accidents is equal to the proportion of women who've been in car accidents, or that the proportion of men minus the proportion of women who've been in car accidents is equal to 0. And what we want to know is there actually a difference? Or do we want to see if women, or whichever. But we're just going to say, is there a difference? So we're not going to say that a greater proportion of men get in car accidents, or fewer women get in car accidents, or something like that. We're just going to say, is there a difference? Okay? So what is our observed difference? Okay, so this is what the null hypothesis is going for, something about the population, right? This is the population of all men and the population of all women, and we're looking at the proportion of all men and all women who get in car accidents. And that's what we're going for in the population, but what we observe, what did we observe?
0.04 is the difference.
Yeah, the difference. So the proportion of men, p hat men is 120 over 500, 0.24, and the proportion of women who've been in car accidents is 60 over 300, 0.20. So my observed difference is equal to 0.04. So I observe a difference of 4% between the men and the women in terms of who's been in a car accident. Is that 4% large or small? Okay. Well, we've got to figure out what our... So according to our picture, okay, and our null hypothesis, what value goes in the middle? In this case, 0. And what I observe? 0.04. I observe a difference of 0.04. And I want to know, what's the probability of being out or greater? And this is, remember, when you have a not equal to sign here, our p-value is going to be the area in the tail times 2. Okay? I know it feels weird, but you'll get the hang of it. So the p-value is area in the tail times 2. And that's because we have a not equal to sign, okay? Because the alternative has a not equal to sign. I know some of you guys are sitting far in the back and you guys are squinting to see. Don't be afraid to move forward, okay? Sit closer up. It makes a huge difference. You've been sitting back there this whole time, you move up a few rows, you'll be like, wow, the board seems so much larger. Okay. Alright, what is my p hat? We gotta figure out p hat in order to get our standard error. So p hat is total number of people who've been in car accidents. So it's gonna be 120 plus 60 divided by 500 plus 300. 180 over 800. 0.225? Thank you. And so my standard error (1 over 500 plus 1 over 300). I'm getting 0.0305. That's my standard error. So what's my z-score? 0.04 minus 0 divided by 0.0305. .31. So I look up 1.31, and how much do I have in the tail? .0951. 0.0951. Okay, so my p-value is I take that area in the tail and I multiply it by 2. Okay, so the reason why is because in my alternative hypothesis I have a not equal to sign. And the not equal to sign is saying there's a difference between the proportion of men and the proportion of women who get in a car accident. So equally interesting, so here we observe 24% of men getting in car accidents and 20% of women getting in car accidents. Okay? Equally interesting would be, so that's a 4 percentage point difference where more men had car accidents. Equally interesting would be a 4 percentage point difference where more women got in car accidents. Okay? So we're looking up both sides of the possibilities. This would be where more men got in car accidents, and this would be where more women got in car accidents. Okay, so we're looking at both. So that's why we multiply it by 2. And so what do I get here? 0.1902, right? So that is my p-value. My p-value is 0.1902. If my alpha is 5%, what is my conclusion? Do not reject the null. And what does that mean? So at this point, I don't have evidence that there's a difference in the proportion of men and women who get in car accidents. Okay, so our p-value is greater than alpha. So this means if men and women get in car accidents at the same rate, at the same frequency, if I take a sample of 300 men and 500 women, I got a 19% chance of seeing a 4 percentage point difference or more. That's what we're saying. Yes?
If it's greater than the null, then we do not reject it, and if it's less than the null, then we reject
Less than alpha, yeah, significant, yeah.
If it's less than alpha, we do not reject it.
No, if it's greater than alpha, if the p-value is greater than alpha, do not reject the null. If the p-value is less than alpha, you reject the null. Okay? I know this is a new concept and it's tough, but try it out, okay? Try to do your statistics homework or problems, multiple times throughout the week, rather than just doing it all on one day, okay? It'll help soak in and learn a little bit. You can, for chapter 8, you can do either the homework problems he assigned, or you can go to my website and look at, I believe, homework 7, and you can try those problems also. A lot of them have solutions written out that might help you and guide you along the way. Entirely up to you. I don't really care about the what you do for the homework. Yes?
Is homework due next week or?
Homework is not due next week. We'll collect chapters 8 and 9 in 2 weeks on the.
Do you have a quiz next week or no?
No, you don't have a quiz next week. You'll have a quiz in 2 weeks. Okay?
Wait, so,
Huh? So we have chapter 8 today, chapter 9 next week, and then the test the following week, right?
yeah.
But you'll give us some like sample.
Yeah, I'll give you a sample for test 3. Okay?
Homework is due
Homework is due, no, in 2 weeks, on the day of the test. Turn in chapters 8 and chapters 9 together.